So hi students. So what we will do. So now this is now chapter number 8. So now there is a topic which is actually a BCD to 7 segment decoder, and why I'm putting it. This topic will be covered in your midterm 2 and final. It is your homework. Any question, any students has any question regarding this thing, so they may schedule a separate appointment with me. Okay. This topic is also your homework. So please do it, and it will be included in midterm 2 and final, and this topic will also be included in midterm 2 and final, and it is very similar to the concept that I explained it earlier. This is how we can implement different functions using decoders. So we already covered this topic. So basically this is like a homework. This topic is a homework for you. So if anyone has any question regarding this topic, they may schedule a meeting with me. Any question? Should we proceed now? Now I'm going to. So that's the reason that I'm writing it here. Homework and included in midterm 2 and final. This is also your homework included in midterm 2 and final. Clear? So now we start with another topic which is called as an encoder. What is an encoder? An encoder performs the opposite operation of a decoder. Okay, and it converts and inputs, and then we have an input output. I will explain this one in an example. So no problem. So what are you going to do? So it is, since it is the opposite of the decoder, so what I'm going to do. So now can you see here? So let's assume we have an encoder here. Okay, now let's assume we have an encoder here. So how many inputs are to the encoder? So can you see here, there are m inputs to the encoder, and how many outputs are there? There are n outputs. Clear? So this is opposite of decoder. This is opposite. And now what is m here? Can anyone tell me what is m here? Can you tell me what is m now? Looking at the figure. Yes, help me. What is m here? So m is equal to, now look at here. Now m is equal to 2 to the power n. Got it or not got it? So how can we write an encoder? So encoder is actually input. If the input is m, so the input is m, so we can call it as m to n encoder. And what is m? M is here. So this is actually 2 to the power n to n encoder. Got it? Any question? Any question? Okay, now what we see, now please look at here. And what is the decoder? Decoder is actually opposite of encoder. So the decoder is opposite of encoder. So now if you look at the decoder, so now this is, now I'm not going to have a decoder. So the decoder has, now if we have a decoder, so it is opposite of encoder. It has how many inputs? It has n inputs. So the inputs to the decoder is n inputs. And how many outputs will be there for the decoder? Anyone may help me. If you will be more and more attentive, I may make the exam easy. What will be the output? How many outputs are for the decoder? Help me. So basically, a decoder has n inputs and m outputs. So this is just like, and what is m? Can anyone tell me? Please help me. What is m?
2 to the n.
To spot n. Okay, now we look at different examples. So now this is how, so this is, can you see here? So these two are opposites. So can you see here, these two are opposite for each other. So these two, this decoder and this encoder are opposite. Any question? Okay, now what I'm going to do, so now we are taking many examples. So let's assume m and now we have n. Let's assume m is 16. What will be n? Help me. Yes. Can you help me?
4.
Yes, very good. So let's assume it is m. So if m is equal to 16, so we can write it like 2 to the power 4 is equal to 16. So what will be n? So n will be 4. And if we talk about the encoder, so the encoder will be, so encoder is actually what? Encoder is actually m2 and now M is 6, so it is actually 16 to 4 encoder. Okay, let's assume M is 64. So we can write it as 2 for 6 is equal to 64. So what will be N here? Can anyone tell me? Help me. I'm not getting any answer. It means the exam will be difficult. Be quick. Speak in mic.
6.
6. So this is actually 64 to 6 encoder. And let's assume M is 32. So basically 2 to the power 5 is equal to 32. So it is actually 5. So this is actually 32 to 5 encoder. Any question? Any question? Should we proceed? Okay.
Yes.
Now what we are going to now explain it what an encoder is. So can you see here? So now we are studying now here we have 4 to 2 encoders. So we have 4 to 2 encoders. So now we have actually the input is M. So now the input is M. So M is equal to now 4. Got it or not got it? And now the output is actually now the green color. So the output is 2. So A1 and A0. So I call this as, so what is N? N is equal to 2. And M is equal to 4. So now we call this as and I'm using the green color. So D0, D1, D2, and D3. Got it or not got it? So basically there are 4 inputs. So we call this as 4 to 2 encoder. Okay, I'll explain this one now in an example. So now I'm now looking into the number of students who are now currently attending here. It's 18 and it's less than 90%. Okay, so now I'm taking 4 students. Okay, so now let's assume there are 4 students. Abdullah is the first student. Okay, Ghala is the second student. Abdullah, Ghala, Kaiser, and Nuruddin. Abdullah, Ghala, Kaiser, and Nuruddin. So Abdullah, Ghala, Kaiser, and Nuruddin. Okay, so now let's assume we say D0 is Abdullah. Okay, so now we can see, let's assume we say D0 is Abdullah, D1 is Kaiser, D2 is Ghala, and D3 is Nuruddin. So now let's assume a scenario, and I want to explain it with an illustrative example. Nuruddin. So now what is the rule for an encoder? So the rule for an encoder is this. So let's assume this is the rule for an encoder. So the rule for an encoder is this: only one student is allowed to raise his hand. Got it or not got it? So this is rule number 1. So if you want to design an encoder, so now this is rule number 1. So only one student is allowed to raise his hand. Okay. So now we can see here. So now we have this is the code for thing. Okay. Now let's assume I assign some codes to different students. So let's assume the code for Abdullah is 00. Yes. What will be the code for Kaiser? Can anyone help me? Please be quick. What should be the code for Kaiser? Anyone help me?
01.
01. Very good. What will be the code for Ghana?
10. And
10. What's the code for Nuruddin?
11.
11. So can you see here? This is actually the code for the index. So if you look at here the code for the index. So now in the index here, because this is D0, so the index is 0. This is D1. Kaiser is D1. The index is 1. And Ghala is the index is 2. So 2. And Nuruddin is 3. So we convert this index into binary. So this is actually the binary of the index. Clear? Any question? Okay, now what we are going to do, so now we have this scenario. So now we have this index. So okay, now the index is actually, so now we can say the index is 0. Either the index is 1, the index is 2, and now the index is 3. So the index, if we convert this into binary, so the index is 0 0, it is 0 1, it is 1 0, and this is 1 1. Okay, now this is now the index, and now can you see here? So this is actually A1 and A0. And what is the input here? So the input is now so now the input is there. So I'm now using the green color. So this is actually D0, D1, D2, and D3. And since we say okay, only one student is allowed to raise his hand or her hand. So if we say if D0 is equal to 1, so then it means so D0, who is D0? Abdullah. Okay, and 0 0 0. So it means that Abdullah raised his hand. Got it or not got it? Okay. Now What should be the input for 0 1? Can anyone tell me? Can anyone tell me what should be the input for 0 1? Please be quick.
0,
0,
1,
1,
0.
0, 0.
0 1 0 0. So this implies that now who raises hands? Kaiser. Clear? And then now you can see 1 0. So okay, Ghala. So this is 0 0 1 0, and then we have D3, which is actually Nuruddin. This is 0 0 0 1. So it means that now Nuruddin has raised his hand, and thus now this implies that Ghala has raised her hand. Any question? This clear or not clear?
Clear, Professor.
Okay, so this is how it works. So this is how it works. Okay, now we can see here. So now we have this scenario. So now we have this four scenario. Can you see here? So now this is my four scenarios. So this is actually what I'm going to do. So I'm going to copy this thing, and now I'm pasting it here. Okay, no, I don't know. This is not working good. So then I can take a screenshot of this. Got it or not got it? Okay, so now this basically, can you see here? Now if we have this encoder, so now please remember for the encoder. So the encoder has four inputs. So the inputs are D0, D1, D2, and D3. And the output is, what is the output? Can you tell me? What are the outputs? A1 and A0. Okay, now if we look at all of the possible combinations, so please remember these are all the, can you see here? These are all the valid, we call this as valid combination. These are called as the valid combination. And if you look at here, what is M here? So M is now 4. So how many possible combinations are there? So possible combination in this example is actually 2 to the power m. Please remember these are 2 to the power m, which is actually 2 to the power 14. Sorry, 2 to the power 4 possible combination, which is equal to 16 possible combination. Out of these 16 possible combination, how many combination are valid? There are 4 valid combination. And how many combination will be invalid? Can you tell me? If anyone
12.
answer.
12.
Yes, so it means that there will be, so can you see here? So there will be actually 12 invalid combination. Now if you look at here, so now this is D0, D1, D2, and D3, and now I have given different names to them. So now if you look at all the names, so what are the names? AKGN, AKGN, AKGN. So this is A, K, G, and N, which is Abdullah, Kaiser, Ghala, and Nuruddin. Okay, now if you look at here, and if I'm commenting here, so what is my comment now? So actually, so basically, if we say 0 0 0 0, it means no one raised his hand. Valid or invalid? Can anyone tell me? Valid or invalid? Help me.
Invalid.
Invalid. Very good. Then the second combination, can you tell me? Who raised hand?
Nuruddin raises hand.
Nuruddin. And valid or invalid?
Valid.
Valid. The second one. Yes.
Ghala raised her hand.
Ghala. And valid or invalid?
Valid.
Valid. Okay, now for the third case, this is now tricky. Now it means that Ghala, G, and N raised their hand at the same time, which is an invalid combination. Because remember the rule. So what was the rule? What was the rule?
Only one student raises their hand.
At only one student raises hand. Any question? Clear?
Professor,
Yes,
do
please
we
go
treat
ahead.
all these invalids as don't cares?
No, 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 no. No, why they are, we cannot say that they are don't care. So basically, these are the inputs. You cannot control the inputs. You can control the output, but you cannot control the input. Input is coming from outside.
Okay.
You got it or not got it?
Yeah, I got it.
Okay, now and I will explain. I will explain later on. After some time, I will explain it why there is a problem in encoder and how can we solve these problems. So I'll explain it later on. Got it or not got it?
I got it.
Okay, so can you see here? Now please look at here. So now if you look at here, this one, this combination is valid or invalid? Help me. This is a valid.
Valid.
This one,
Not
invalid. This one, invalid, this one invalid, and then you can find for all of the possible combinations, and you can say which one is valid or which one is invalid. Any question? Got it or not got it? This is clear?
Yes.
Okay, now what I am going to do, now we want to design a 4 to 2 decoder. So now what we are going to do, so now we are going to design, we want to design a 4 to 2 encoder. What are the inputs? Help me. D0, D1, D2 and D3. What are the outputs? Help me.
A1, A0.
A1 and A0. Got it or not got it? So basically, can you see here? So now this is A1 and A0. Got it? So the input are D0, D1, D2 and the outputs are actually A1 and A0. Clear or not clear? Okay, now look at here. So now can you see here? Now look at here and now look at this thing. Now we are now looking at A1. Can you see here? This is A1. So now I'm now using a black color. Got it? Which color?
Black color.
Black color. Now we want to design for A1. So we want to do one. So can we see A1 will be 1 if A1 will be 1 if D2 is 1 or, so can you see now we can say now we can make a logical argument. So you can say if A1 will be 1 if D2 is equal to 1 or D3 is equal to 1. Got it or not got it? So what will be the expression for A1? So A1 will be 1 if D2 is 1 or D3 is 1. So what will be the expression for A1? This is actually A1 and A0, and which is actually sorry, this is wrong. So this is actually the input is D2 and D3 and the output is A1. Now let's say if you want to find an expression for A0, can you see it's here and A0. What can I write here? Can you see? A0 will be 1. Yes. If what? Can anyone help me? Please, can you anyone formulate? Looking at a truth table.
If D0 equals 1 or
No. How do you say? I'm now looking at the no. This the green color. If what?
if D3 equals 1.
Yeah. If D1 is equal to 1 or D3 is equal to 1. Got it or not got it? So the expression, what will be the expression for A0? Can you help me? Help me.
D1 plus D3.
D1, D3.
Any question? Any question? Should I proceed? Okay. Now what I'm going to do, so I'm going to doing with this with different examples now. Got it or not got it? So what I'm going to do, so now these are the expression. So now these are the expression for, so can you see here? So this one and this one. So now I'm making it here. So this is the first expression. Now this is the second expression. Got it or not got it? Okay. Now what we are going to do, now we take all the possible combination. Let's assume Let's assume that we look at okay, now we are only considering the valid combination. So now what I'm going to do, so now I'm the valid combination. So the valid combination 1. What is the valid combination 1? The first valid combination. The first valid combination is D0 is equal to 1, D1 is equal to 0, D2 is equal to 0, and D3 is equal to 0. Am I right? Okay, now if you go and if you look at here and you apply this to the first valid combination, so it means D1, D2, and D3 are 0. So this is actually 0, 0, 0, and 0. What is A1? 0 and 0. My output is correct or incorrect? Yes, help me.
Correct.
Correct. Okay, now I'm now looking at the second valid combination. What is the second combination valid combination? D0 is 0, D1 is 1, D2 is 0, and D3 is 0. Now I want to do the same thing. Now I'm copying it and paste it here, and as you do it in your homework. So D0 is 0, D0 is not here. D1 is 1, D1 is 1, so D1 is 1. D2 is 0, D2 is 0. D3 is 0, so D3 is 0 here and D3 is 0. And 0 plus 0, it is actually 0. And 1 or 0, it is actually 1. So this is the second valid combination. Got it or not got it? Any question? Clear or not clear? Yes? Am I right or not? Yeah. So now I'm now looking for the other valid combination. Now looking for the other valid combinations. So now this is my other valid combination. So now I'm looking at the other valid combinations. Hmm. Okay, just okay, I can make it here. What is my third valid combination? Can you tell me third valid combination? Yes. D0 is what? 0. D1 is 0. D2 is 1. And D3 is 1. So D2 and D3 are 1. So D3 is 1. D2 is 1. Okay. And D0 is 0 and D1 is 0. So D1 is 0. No, no, no. What is the third valid combination? Sorry. D2 is 1 and D3 is 0. So D1 is 0 and D3 is 0. What is the output? Can you tell me? A1 is what? 1 and it's 0. So can you see this is the output is 1 0, which is the same thing. And what about the fourth valid combination? Can you tell me? So now I copy and paste it here. Control C, and then I'm doing it here. Control V. In the four valid combination, D3 is 1. So D3 is now 1. So D3 is 1, 0. D3 is 1, and it is 0. So 0, 1 is 1. And any question? Is clear or not clear? Yes, students.
Professor, so you don't include D0?
Because for D0, so it means that no one will raise his hand. So basically D0, basically the code is 0 0, and then D0 is 0. So in all of the cases, because now we have make the assumption, that only one student is allowed to raise her hand. So now now the question is this. Now the question is this: Is my output valid for all the valid combination or not? Is my output correct or incorrect for all valid combination or not? Yes or no?
Yes.
Yes. And now you'll see that why this encoder will a problem for an invalid combination. Got it or not got it? So now I will explain this with an example. I will explain this now with an example. Okay. So now let's assume now that we have this output. So now we have this output. Can you see here? So now we have this decoder. And now can you see here? So now this is my copy, and I'm copying it and I'm pasting it here. So let's assume we have the same thingy. No, I can make it. Now I'm copying this thing and I'm pasting it here. These are the valid combination and invalid combination. Can you tell me? Yes, these on the right. These valid or invalid combination? Got it or not got it? So now we want to see like two problems with the encoder. Now there is a problem. There are two problems with the encoder. What is problem number one? I will explain this with the problem number one. Problem number one. Now the problem is that, so if we have an invalid combination and that invalid combination is like D1 is 0, D2 is 0, D3 is 0 and D4 is 0. What does it imply? It means that no one raise his hand. And please remember, we said okay, in the valid combination at least one student should raise his hand. Got it or not got it? So now in this case, what will be my output here? So now my output here will be, now if I see with this invalid combination, so now D2 is 0, D3 is 0, D1 is 0 and D3 is 0, so the output will be 0 0, and 0 0 implies that D0 raise hand, which is correct or incorrect? Help me. Got it or not got it? Any question? This is clear or not clear? If I'm not hearing any answering from you, the exam will be difficult. Maybe many people are sleeping. Yes, Junaid, Zafar, James.
Clear, Professor.
Okay. Now this is the problem number one. Now I want to highlight problem number two. Now I want to highlight problem number two. And what is problem number two? So let's assume I'm now looking at problem number two. So now I'm looking at problem number two. Let's assume the combination is D0 and D1 and D2 and D3. So D1 is 0. Clear? And D1 is 1. Okay. D1 is 1 and D2 is 1 and D3 is 0. What does it imply? Can you tell me? Who raised his hand? Help me.
Both Qala and Kaiser.
D1 and D2. Got it or not got it? Now if you look at for this combination, so if we go for this, so for this combination, what will be the value of D2? D2 is now 1. D3 is 0. Got it or not got it? D0 is not there. D1 is 1. D1 is 1. And what about D3? D3 is 0. So if you look at the output, what is my output? 1 and 1. And 1 1 is a code for what? 1 1 is a code for D3, which is correct code or incorrect code?
Incorrect.
Yes, incorrect code. Got it or not got it? So there is a problem associated with an encoder. So there are two problems associated with the encoder. The first problem is that if no one raises his hand, it will always give us the code for D0, independent of the size of the decoder. And the second problem is that if there is another invalid combination for which two or more students raises their hand, it will also give us an incorrect code. Got it or not got it? Any question? Clear or not clear?
Clear.
Okay, now the question now arises. So now the question arises how can we address problem number 1 and problem number 2? If anyone will answer me this question, both an answer to both problems, he will get 1 bonus mark. So now we have a 4 to 2 encoder. So the input is actually D0, D1, D2 and D3, and the output is actually A1 and A0. So this is actually 4 to 2 encoder, and now we want to solve problem number 1. No one raise his hand. It means all inputs are 0. And problem number 2, if multiple inputs are 1, all inputs are 0, it means it will give the code for D0 always, independent of the size of it. And if multiple inputs are 1, so the the output of encoder will be invalid. How can we solve problem number 1 and problem number 2? Can you tell me? Anyone may answer. Yes.
Do we have to like give some of the bits priority? Like as in it doesn't take all of them the same way? I don't know how to describe it, but I mean like
Okay. And how can we solve problem number 2, the other problem? So okay. Now your answer is that okay, we can assign some priority. So the priority will solve problem number 1 or problem number 2?
problem number 1.
The priority.
Yeah, it would solve problem number 1 because it would.
Sorry, no, it should solve problem number 2, because if there are multiple, so we need to decide who raised their hand.
Mhm.
So the priority will solve problem number 2. So now you can say, okay, now we can assign for problem number 2, we can assign priority. How can we solve problem number 1? So solution. And I'll explain the solution in my next slide. How can we solve problem number 1? Can anyone answer me?
Maybe it has something to do with the enable.
Yes, you're I think very close. So we can introduce some another output. We call this as a valid output. So we include a valid bit at the output, and the valid bit to say whether the input is valid or invalid. And how we can solve this problem? We can do it in the next slide. Got it or not got it? So now you can see it in the, so we have 2 problems. So now this is problem number 1 and problem number 2. So now if no one raises their hand, so D0, which is not true, and these are 2 problems. How can we solve this problem? So we can solve this problem with this thingy. I'll explain also with this example. Okay, so basically what was the code for all the students? Can you tell me what was the code for? So this is actually no. What were the name of the students? Can you tell me the name of the students who were involved? Abdullah, AKGN. Okay, now we have the same problem, and now we have some inputs, which is actually we call this as D0, D1, D2, and D3, and then we have the outputs, which is actually A1 and A0, and this is actually A, K, G, and N. A stands for Abdullah, K for Kaiser, G for Ghala, and N for Nuruddin. So this is actually a thing. Okay, now, so we instead of doing designing this so we had a 4 to 2 encoder previously. Now we call this as 4 to 2 priority encoder. So we are assigning a priority encoder. And since we have a 4 to 2 priority encoder, so we also include a valid bit. So the valid bit will tell, okay, that whether the input combination is valid or invalid. This is a valid bit. So V stand for valid. Got it or not got it? And now what we decide that now we are deciding some priority to each student. So now so now if we say, oh, now I'm giving priority to Nuruddin, so it means that Nuruddin has got the highest priority. So it means that n Nuruddin, which is actually D3, has got the highest priority. So now I'll explain this. Let's assume if I'm the professor, and then two students or more students raises their hand to whom I will service. I will explain this with an example. So now if we say, so now since I have the priority, so I say, okay, Nuruddin has got the highest priority. So let's assume we have D0, D1, and D2 and D3. Okay. So in this case, we can say, okay, now it is actually A, K, G, and N. So let's assume if we have 0, 0, 0, sorry, 0 1 0 0. Okay, whom I will service, so I will comment. So whom I will service, I will answer Kaiser. And since I will answer Kaiser, so the code is very simple. It's a normal encoder. So I will answer Kaiser. Where's the code for Kaiser? So the code for Kaiser, it is 0 0 0 1 1 0 and 1 1. So the output A1 and A0 will now be, so this is A1 and A0. So the output A1 and A0, because it's Kaiser, the code is 1 0 1. This is very simple. This is not. But if we have the code for D0, so this is 0 1 and 1 and 0. Okay. Who has got the highest priority between Ghala and Kaiser? Yes. Anyone may answer. I'm not hearing the answer. Yes. Do you hear me? No. Who has got the highest? Nuruddin has got the highest priority. The next priority is for the Ghala. Then the next priority is for the Kaiser, and next priority is for Abdullah. So the priority start with the higher index. To whom I will answer? I will answer Kaiser or Ghala? Ghala, because Ghala is the highest priority. So which means is Ghala. So Ghala, and what is the code for Ghala? So the code for Ghala is 1 0. Okay, in this case, valid bit will be 1 or 0. So the valid bit here will be 1, and it's also 1. So now in the priority encoder, so it is, so we exclude the rule. So it means that two inputs can be enabled at the same time. Can be enabled at the same time. Two or more inputs can be enabled at the same time. So if we assume, so now let's assume if we have like this 1 and 1 0 and 0, what will be the output? Can you tell me? Who has got the highest priority?
Kaiser.
Kaiser. So Kaiser will, and what is the code for Kaiser? The code for Kaiser is 0 1 and the valid bit is 1. And if no one raises their hand, 0 0 0 0, so no one raises their hand, what will be my output? Can you tell me? Yes.
Invalid.
So the valid bit will be 0 here. So because this is invalid, so in this case the valid bit will be 0, and we ignore the output and don't care. And why don't we are using don't care? Because don't care is used to do the logic minimization. Any question? Got it or not got it?
Got it.
Okay. Now how can we do that? So we can then draw the truth table for this. Okay, so now what we can do, we can draw the truth table for this, and I will explain this with an example. So now can you see here? So now I can draw the truth table for this. We have the same truth table. So now what I'm going to do, so where is the encoder? So this is my encoder. This is my priority encoder, and this priority encoder has another output, which I call this as valid, which is called as V bit. Okay, so for V This is A1 and A0, and now it has a B bit. Got it or not got it? So okay. Now how many possible combination of all these things? So can you see here? So now we have the input is actually D3, D2, D1, and D0. And how many combinations are there? 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, double 1, 1, double 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Got it? And then we have 1, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, double 1, 1, double 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Now, if you look at all of these combinations, so now basically, can you see here? So now we can say this is my Nuruddin, this is A, K, G, and N. So it means that now Nuruddin has raised his hand. Got it or not got it? So Nuruddin, so we ignore Ghala, Kaiser, and so because raise his hand. So what will A1 and A0 here? Help me. What is the code for Nuruddin? So Nuruddin, so we have A, K, G, and N. So Nuruddin 1, 1 is 1, 0, this is 0, 1, and this is 0, 0. Got it? So it means that Nuruddin has raised his hand. So it means we ignore the other one. So when we ignore the other one, so the code will be actually 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and 1. Got it or not got it? So this is the code for Nuruddin. Now in this case, now we are now going for the other case. So now we are going for this case. Okay, Nuruddin hand is down. Okay, now whose priority is this? Now the priority is for Ghala. Here the priority is for Ghala. And what is the code for Ghala? It is 1, 0. So it is 1, 0, 1, 0, 1, 0, and 1, 0. Got it or not got it? Any question? Okay. Now can you see for the other two possible combinations? So now the other possible combination is with the black color. In this case, D3 is 0, D2 is 0. So now we can say Kaiser has raised his hand. So now can you see here? What is the code? What is the code for Kaiser? The code for Kaiser is 0, 1. 0, 1, and 0, 1. So Kaiser has got the highest priority. And the last combination is the poor Abdullah, which has got the least priority. So now this is 0. So this is 0, 0, and it's Abdullah. And now if we look at here, so this is actually invalid combination. So we ignore it. So we have XX. And now in this case, valid will be 0. And for all of these combination, valid will be 0 or 1. Any question? Any question? I'm not hearing you.
Professor,
Yeah, please go ahead.
how would you implement the priority? Like, I mean, like with the gates, like logically, how would you actually implement it?
Okay, I will do it. I
Okay,
will do it now.
okay, sorry.
And why? Now you have the K-map. When you have the K-map, what's the problem?
Oh, so we just use K-maps?
Yeah. So basically now
Okay.
the thing is copy, and then I can see it. Okay, now because now there is a logical explanation for this. Got it or not got it? So now what I'm going to do? So now I'm good. You know what I'm going to? I'm now going to rub this off. So now we have got it or not got it. So this is I'm now using it here, and I will explain it. No problem. I'm here. I'm here. Okay. So what I'm going to do now? Okay. Just look at the thing. If you convert this into okay, let me convert this into binary. So what will be the binary? It is actually 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So can you see? Now let's do. What is now my A1? So can you see now I'm using it A1. So this is my A1. So A1 is now sigma m of what? Can you help me? What is A1 now? Help me. Yes. 4, 5,
4 to
6,
15.
7, 8, 9. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Are you understood? How can I express A0? Help me. Sigma m of what? Help me.
2, 3, and 8 to 15.
Yes, 2, 3. So now we have A0. So now can you see here? I'm now using a different color for A0. So it's actually 2, 3, and 2, 3, 8, 9, 10, 11, 12, 13, 14, and 15. Clear or not clear? Yes or
Clear.
no?
Clear.
Okay. Did I answer your question? Yes.
Yes.
Okay. Now, what will be the value of valid bit? I can directly derive the expression using so. What will be valid bit? So valid bit will be 1. So can I say valid bit will be 1? So now I'm going logical explanation for this. So valid. So can I say so valid bit will be 1. So valid bit will be 1 if d3 is equal to 1 or d2 is equal to 1 or d1 is equal to 1 or d0 is equal to 1. So what is v? So v is actually d3 plus d2 plus d1 plus d0. So this is the expression for. Any question? Any question? Well, it is easy or difficult?
Sorry?
Valid bit is easy or difficult? I'm asking you.
Easy. Just so this is only implemented for when no one raises their hand, right?
Yeah.
Okay.
So if no one raises their hand, so this is 0, 0, 0, 0. So valid will be 0. If any of them is 1, valid will be 1. Am I got it or not got it?
Got it.
And then how can we derive this thingy? So now, okay, now what I'm going to do, so now can you see here? So now please look at here. This is very simple. Now what I'm going to do. So now if I'm solving this thingy, so now I'm taking a screenshot of this. I'm saving it because it may, you may lose some work, so I want to. Okay, got it or not got it? So this was the thingy. Okay, so this is very simple. Now can you see here? This is sigma m something like this. So what is a1? So in this case, a1 is now a function of d3, d2, d1, and d0. And now if you draw the k-map for a1, so this is now a1, the k-map for a1. So remember the k-map. Remember the k-map. So this is actually d3, d2, d1, and d0. How many ones will be there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 ones. So this is actually 0, 1, 3, 2, 4, 5, 7, 6, 8, 11, 9. So please remember, CAMAP will be included in every of your future things. So that's the reason I put very, so 8 plus 4, 12, 9 plus 4, 13, 11 plus 4, 15, and this is 8 plus 4, 12. So now we can see here, so now I want to solve for A1. What I'm going to do now, I'm now using the red color. If I'm using the red color, so 4, 5, 6. So 4, 5, 6. So these are all. There will be
Professor,
12 ones. Yeah?
third root's 14, 12, 13, 15, 14, and the fourth row also.
Okay, so this is 10. You want to write about this? 10, yes? Is it right? Am I correct now?
Correct.
Okay. So can you see here? This is now the CAM map. And now if it's the CAM map, so how many groups are there?
2 groups of 8.
2 groups. So now you look at here. So there are 2 groups. So now there are 2 groups. So now this is the first group. And what's the second group? So now this is the second group. And then you can find the expression. So similarly, you can find the expression for A0. So what is the expression for A1? So A1, if you look at for the blue group, so the blue group, so this is 0, 0, 0, 1, 1, 1, and 1, 0. This is 0, 0, 0, 1, 1, 1, and 1, 0. For the blue group, it is actually D2. And for the black group, plus D3. And similarly, you can find the expression for A0. So now I'm going to, so it is already there in the lecture slide. So basically what I can do here, so now can you see here? Now please look at here. Got it or not got it? Any question? Clear?
Clear.
Okay. So now this is the thingy. Please look at here. I have solved it here. So this is the 4 to 2 binary encoding. So this is the KMA for A1. Got it? Any question? Clear? So now this is actually the expression for A1. So now the expression, what is the expression for A1? So the blue thing will give me what? So this is D3, D2. So it will give me D2. Got it? And the red one, help me. D3. So A1 is now D2 plus D3. So this is my A1. And this will give me D3 plus D2. And similarly, we can solve for the KMA for A0. So for KMA for A0, we can make a big group. So that this is the thing. So what is the expression for A0? So if you look at here, A0. So now you look at the green one. What is green one? Please look at here. Green one is D3 plus, and now we have this group. Can you see this group and this group? So now we go from this here to here. We go from here to here. So this is actually D3 plus, from here to here, D2 bar, and from here to here. Yes, can you tell me which is changing? D1. And this is the expression. And the valid bit is actually, what is the valid bit? And we explain it. So this valid bit is D3, D2, D1, and D0. So this is the whole circuit of 4 to 2 priority encoder. Any question? Any question? Clear?
Yes.
This is clear or not clear?
Clear. Professor, so whenever
Okay.
you have a priority encoder, you need a valid bit for it? Or
Yes, we need a valid bit. But for, okay, now what I'm going to do, okay, now I didn't cover it now, but I will explain it now. So let's assume we have a 8 to 3 binary encoder. Okay, now in the previous example, we derived the expression of 4 to 2 binary encoder, but we want to now derive the expression for 8 to 3 binary encoder. Please remember, it's not a priority encoder. It's not a priority encoder because there is no valid bit here. So can anyone tell me what will be the expression for A2? What will be the expression for A2? Can anyone tell me? What will be the expression for A2? So A2 is here, A2 is here, A2 is here, A2 is here. Yes? What will be the expression for A2? Because a simple priority encoder does not need a K-map.
D4 plus D5 plus D6 plus D7?
D4 plus D5 plus D6 plus D7. So this is D6. What will be the expression for A1? Help me.
D2 plus D3.
Very good. D2
6,
plus D3.
D7.
Got it or not got it?
You got it.
Okay. What will be the expression for A0? Help me.
D1 plus D3 plus D5 plus D7.
Got it or not got it? And what about the how can we design? Okay, can anyone tell me, if anyone will answer me this question, we may get some bonus mark. How can we design? Is it possible to design an 8 to 3 binary encoder, priority binary encoder? Anyone will answer me this question, may get some bonus mark. Anyone? Yes or no? Yes, James? Nuruddin? Khala?
Yeah, Professor, I don't know.
Okay, so now can you see here but it is not possible. Why? Because if we want to do it and we need to use a chem map. And now what is n here? Please remember. Now can you see here what is m here now? In this case, m is, what is m here? M is 8. When m is 8, there will be 8, so there will be 8 tools for 8 possible combinations. Got it or not got it? So when there is 2 possible, how many of them are valid? There will be 8 valid combinations and 248 invalid combination, and it is very difficult to design such using chem map. You got it or not got it?
But it
You
is
get
still
it?
possible, right?
It is still possible, but we can design this using multiplexer, but it's not the topic of today's lecture. We will cover it later on.
Okay, Professor.
Got it or not got it? It's clear or not clear?
Clear.
So we will do it in when we will cover the multiplexer. So I will answer your question. This question: how can we design a priority encoder using multiplexer? We will cover it in our next lecture, but not today. Got it? Now, what is now a multiplexer? So now we are starting with another topic, which is a multiplexer, which is actually in another lecture, lecture number 9. So now what we are going to explain. So now I'm going to explain multiplexer or select. For that, I need to have the students of 2 more students, maybe James. James is for 1 student, and Shama. So these are 2 students, James and Shama. So let's assume we have James. So D0 is James. And D1 is Shama. And let's assume Y is my chair. And let's assume S is the professor. Why I'm going to give an example. This is very important. Okay. What does it say? So it will say, now the question arises now. We can say, so I'm giving some very simple example. So who will sit on the chair? Who will decide? Who will sit on the chair? Who will decide? Help me. Yes, can you tell me who will decide that who will sit on the chair in this example? I'm not hearing from you. Please at least answer.
Shama?
No, professor will decide. Professor. I have the authority. Shamas doesn't have any authority. I just give. So professor will decide who will sit on the chair. Or professor will decide who will speak. You cannot say. Sorry, who will sit on the chair, the professor will decide. So there are 2 possibilities for S, which is professor. So if S is 0, who will sit on the chair? D0, because D0 is the index. So D0. So D0 will sit on the chair. And if S is equal to 1, who will sit on the chair? D1 will sit on the chair. Got it or not got it? Clear or not clear? At least you know the functionality. This is clear or not clear? Help me. So who will sit on the chair? James will sit on the chair, and in the second example, Shama will sit on the chair. Got it or not got it? So this is how this is the functionality of a 2 to 1 multiplexer. Now let's assume we have a 4 to 1 multiplexer. So this is the block diagram of a 2 to 1. Now let's assume we have a 4 to 1 multiplexer. Again, in the previous example, there were two contenders. There were 2 guys who were competing. It means James was competing and Shama was competing. But now we have 4 people. So in this example, now we have a 4 to 1 multiplexer. So in the 4 multiplexer, there are 4 people. So I call this as James. James is D0. Shama is D1. And now I can go for 2 more students. Let's assume I just randomly pick them. So this is Junaid and Hamad. So Junaid is another student. And Hamad is another student. And now the professor, this is now the professor. And again, Y is the chair. Who will sit on the chair? So let's assume now the professor. Now professor is 2 bits now. So can you see here? So the professor has 2 bits. So we have S1 and S0. So 0, 0, 0, 1, 1, 0, and 1, 1. So what is the index? the index here is 0, 1, 2, 3. And who will sit on the chair? Because who will sit on the chair? So it will D0 will sit on the chair, D1 will sit on the chair, D2 will sit on the chair, and D3 will sit on the chair. So let's assume if we say, so if professor code is S1 and S0 is equal to 10, who will sit on the chair? Anyone may answer.
Junaid?
Yes. So Junaid will sit on the chair. So it means that y will be equal to, so y will be equal to Junaid, or y will be equal to D0, sorry, D2 if S1 S0 is 10. Any question? Is it clear or not clear?
Clear, Professor.
Clear. Okay, now how can we design a multiplexer? So how can we design a multiplexer? So this is the block diagram of a 2 to 1 multiplexer. So now in this example, since there were two students, which is James and Shama, so I call this as J. So James is J and Shama is S. And okay, Shama, I can call it as M, because you know there is S here. So M is Shama, and this is S, which is actually the professor. And now my output is Y. So what will be the value of Y? So can we say Y? So there are two possibilities for S. So S will be 0 or S is equal to 1. If S is equal to 0, who will sit, D0 or D1? Help me. I mean, S is equal to 0.
Junaid will sit D0.
Yeah.
D0. And if S is equal to 1, then
D1.
D1.
So can we see? So we can write S here and plus and S here. So if S is equal to 0. So if S is equal to 0, so we have bar here. Got it? Since we have a bar here, so because S is equal to 0. So then who will sit? D0 will sit. And F is equal to 1. So there is no bar, and then D1 will sit. So this is the expression for a multiplexer. So can you see when S is equal to 0? So this is actually the first condition. And then when S is equal to 1, this is the second condition. And what is Y? So Y is actually, so we need a 2 AND gates. So this is actually S bar and D0 pass, and then we have S when S is equal to 1, and then we have D1, and then since we have plus, we have an OR gate, and the output will be Y. Any question? Clear or not clear?
Clear.
Am I right or no?
Yes.
Okay, now how can we design a 4 to 1 multiplexer? Okay, so now how can we design now a 4 to 1 multiplexer? So now this is my 4 to 1 multiplexer. Can you see here? So this is my 4 to 1 multiplexer. And let's assume there are 4 students, and so I named them students by D0s. Who is D0 in the last examples? James, Shama, Junaid, and Hamad. So this is James, Shama, Hamad, James, Shama, Hamad, and no, James, Shama, Junaid, and Hamad. Junaid and Hamad. These were 4 students. Got it? Okay. Now, so let's assume if S is equal to 0, then there are 4 possible. S is equal to 1. So again, I'm now using different colors for it. Why I'm using different colors? Because colors are always good. So let's assume S is equal to 0. I'm using now the green, the blue color, and then S is equal to 1. I'm now using a red color. Let's assume S is equal to 2. I'm now using the green color, and now if S is equal to 3, I'm now using the black color. If S is equal to 0, who will sit on the chair? Help me. Help me. Answer me.
James.
James or D0. The index is 0. If S is equal to 1, who will sit?
Shama.
Shama, which is D1. And if S is equal to 2,
Junaid.
yes, Junaid. And if S is equal to 3,
Hamad.
Hamad. Okay, now we look at the code for each thing. So the code for this S is equal to 0 is 0, 0. For s is equal to 1 is 0 1. For s is equal to 2 is 1 0. For s is equal to 3 is 1 1. Got it or not got it? Any question? Clear? So what will
Clear.
be now my y? So now what will be my y now? So my y will be equal to my y. This is my output. So now I'm using different colors. So I'm using the black color. So this is, I can call it S1, S0 because now this S is now two inputs. I call this is S1 and S0. S1 and S0. Then S1 and S0. Then I'm replicating it. S1 and S0. And then I'm replicating S1 and S0. Got it or not got it? So when both of them are 0 0, so both of them are 0 0. So basically it's 0 0. So 0 0, who will pass? D0 will pass. And if it is 0 1, so there will be a bar on S1. 0 1. So this is 0 1. So this is 0 1. Got it? And then D1 will pass. Plus. Okay, for the green one, where will be a bar? Where will be a bar there? Bar on what? Can anyone help me? For the green one.
On S0?
Yes, there will be bar on S0. And for S S is equal to 3, where will be a bar?
There is no bar.
There is no bar. So what will be the output? So this actually now I can include because it's D3. So D3 will pass. So this will be. Any question? Okay. Now if you can transform that thingy. Okay. So now if you transform this thingy, so that this is now my final expression. So now what I'm going to do, so now, this is the expression will be very simple. So this is the the first one, then this will be the second one, then there will be the green one, and then there will be the black one. So this is actually what? So this is one is actually, so the first expression will be actually D0, and then we OR them all of together. So I'm now using this color. So this will be actually the OR gate. This will be Y, and this will be Y. So this the first thing will be what? So now we have S1 and S0. So can you see here? So now we have the blue color. Where is the blue color? Oh man, the blue color is gone now. But now I can do it here. So this one is so we have S1. So S1 is here, and this is S1 bar. So we have S1 bar, and then we have S0, then we have S0 bar, and the third thing is D0. Clear or not clear? Now what I'm going to do, so now I'm going to use this thingy. So we have S1 bar. Where is S1 bar? S1 bar is here. And S0, where is S0? S0 is here. And now we have D1 here. What about the green one? S1. So the green one is S1. So S1 will come from here. The second thing is S0 bar. S0 bar will come from here. And now what is D2? So now we have D2 here. And the last one is the black one. So this is S1. So you can take this from S1 because this is S1. And now we have S0. So where is S0? S0, S0 is here. And now we have D3. This one. Any question? Any question? Clear or not clear?
Clear, Professor.
Okay, so this is all the topics. So now this is all the topics that I'm now covering. So now what I'm going to do, so I'm now stop sharing now, and I'm now doing what is this thingy. So now we have stop recording.